Why is space so cold? We see stars burning like fiery torches, yet between them stretches a frozen void. At first glance, it seems the universe should be scorching hot. But the reality is far harsher. Space is mercilessly cold, nearly to absolute zero. Space is nothing like Earth, where air carries warmth. Out here, there is no air, no molecules to store or move heat. That's why even near a blazing star, the shadow remains deadly cold. This extreme temperature contrast is one of space's greatest mysteries. Temperature in space depends on radiation. Without an atmosphere, objects heat up quickly under starlight and cool just as fast in shadow. On the Moon, daytime can reach plus 120 degrees Celsius, while nighttime drops to minus 170 degrees Celsius. This contrast shows how vital Earth's protective atmosphere really is. Space is not cold because of frozen air. Its coldness is the absence of everything: matter, warmth, and motion. Only particles of radiation cut through the silence of the void. But there are far too few to heat the cosmos. Scientists have measured the temperature of empty space, about 2.7 Kelvin. That's only a few degrees above absolute zero. This leftover warmth is the echo of the Big Bang, a whisper from the universe's birth. Every inch of the cosmos carries this frozen reminder. Absolute zero is the limit where atoms stop moving. It equals minus 273.15 degrees Celsius. In space, conditions come close to this boundary, and matter is nearly motionless. This makes the cosmos the coldest place we can imagine. But if space is so cold, how can stars burn for billions of years? The secret lies in nuclear reactions within their cores. There, pressure and temperature reach millions of degrees. Only these fiery giants pierce the frozen darkness. Stars emit heat, but in space it disperses quickly. Without air, energy travels only as radiation. That's why heat doesn't spread evenly, but shoots in beams into the void. This is why the universe feels frozen, despite billions of burning suns in Earth's orbit. This phenomenon is especially strong. Astronauts know that in sunlight, a spacesuit can heat up to plus 120 degrees Celsius. But in the station's shadow, the temperature drops below minus 150 degrees Celsius. Such contrast is dangerous and demands advanced protective technology. To survive, spacesuits are equipped with cooling and heating systems. They function like miniature spacecraft, maintaining stable temperature. Without them, an astronaut would die in just minutes. This is how humanity fights against the frozen nature of space. The cold of space affects not only humans, but also technology. Electronics, batteries, and materials can fail under extreme temperatures. That's why spacecraft are equipped with insulation and radiators. Without them, journeys into deep space would be impossible. Imagine a space probe traveling toward Pluto. The farther it moves from the Sun, the colder the surroundings become. Starlight can no longer reach it, and temperatures fall close to absolute zero. Here, eternal frozen darkness rules. Yet even in deep space, there are bursts of warmth. These are quasars and pulsars, releasing colossal energy. They shine like beacons in the frozen void. Their light reminds us, space is not only cold, but also full of fire. Earth is unique. Its atmosphere and oceans distribute heat. That's why we don't experience such extreme contrasts as in space. Our world is a warm island in the cold ocean of the universe, and this is what makes it a home for life. Space is cold, but this very coldness shapes stars, planets, and galaxies. In cooled clouds of gas, new suns are born. The contrast of heat and cold drives cycles of creation and destruction. Without cold, the universe would not be what we know today. When scientists study the cold of space, they use special telescopes. These capture invisible thermal radiation, infrared waves. It lets us peer into the darkest, coldest corners of the universe. There, new stars and planets are born. The coldest place in the universe was found in the Lagoon Nebula, There, the temperature is just 1 Kelvin. That's colder than the cosmic microwave background itself. In these frozen pockets, stars are born out of nothingness, but even on Earth, scientists can create extreme cold. In laboratories, they cool atoms almost to absolute zero. These experiments help us understand the laws of the cosmos. It's as if we recreate the universe's own cold. The cold of space also shapes the future of interstellar travel. Ships will have to endure millions of kilometers of frozen emptiness. Heat and energy will become the most precious currency. Perhaps cold itself will set the limits of our expansion into the cosmos. But cold is not an enemy. It is part of cosmic balance. Without it, stars and planets would never form. It creates the conditions for the endless cycle of life and death in the universe. Cold is the breath of the cosmos. When a spacecraft travels far from Earth, the sun's warmth grows faint. Its rays are no longer enough to provide heat. That's why engineers use radioisotope generators and heat-preserving systems. Without them, the cold of space would quickly consume the craft. Even space stations orbiting Earth face the cold. Every 90 minutes they pass from sunlight into Earth's shadow. Their hulls must endure sudden, extreme temperature shifts. It is a constant battle with the cold of space. Space teaches us to value warmth. What seems ordinary on Earth, sunlight, fire, the breath of wind, becomes a luxury in space. Warmth means life, and its absence means a cold death. That is why explorers prepare so carefully for every mission. But space is not only cold, it is beautiful in its silence. Billions of stars shine like sparks in an endless frozen void. This beauty exists because of the contrast between cold and light. Cold makes the stars shine brighter. Scientists believe that cold helped the universe form galaxies. Without cooling, gas would never have collapsed into stars. The contrast of temperatures became the engine of cosmic evolution. Cold is not an enemy, but the builder of the cosmos. We often think of space as just a frozen emptiness. But in truth, cold is the foundation of its dynamics. It is the cooling of gas that triggers the birth of stars. Without this process, the universe would remain empty and faceless. The cold of space also explains the rarity of life. Most planets are too frozen to sustain liquid water. Earth is an exception, perfectly balanced in its position. We exist only because of this fragile equilibrium. Even galaxies age and grow colder. In their centers, stars die, and less heat shines into the dark. Trillions of years from now, the universe will be even colder. Scientists call this the heat death of the universe. Cold does not only destroy, it preserves. Comets, frozen for billions of years, carry ancient secrets. They hold water and organics from the birth of the solar system. These icy wanderers are the archivists of space. When a comet nears the sun, its ice evaporates and it comes alive. From a frozen block, it turns into a blazing torch. Thus cold and heat create the grandest shows of the cosmos. And each glow reminds us of the universe's fragility. Space is cold, yet this cold helps preserve the past. In interstellar clouds lie molecules that have existed for billions of years. They remain untouched by time because of the low temperatures. It's as if they are frozen letters from antiquity. In the depths of space exist even colder objects, brown dwarfs. They are too small to ignite like stars. Their surfaces can be colder than a winter's day on Earth. These failed stars wander in darkness, giving off faint warmth. Sometimes the cold of space becomes a deadly trap. Spacecraft without power freeze forever. They turn into icy monuments to human dreams. These silent witnesses drift endlessly in eternal darkness. But for science, even this frozen silence has value. Frozen probes become part of the history of exploration. They remind us that every step into space is a battle with cold, and that humanity is learning to conquer even eternal darkness. The future of space missions depends on how well we can master the cold. We are developing new materials to withstand extreme temperatures. We design systems that preserve warmth in deep space. Each step brings us closer to the stars. In the distant future, cold may become humanity's greatest enemy. If the universe keeps expanding, stars will burn out. Then only eternal darkness and cold will remain. Scientists call this the fate of a frozen universe. But for now, we live in an age of warmth. Stars still burn, planets still shine. Our world is surrounded by energy we rarely appreciate. And cold reminds us that this miracle is not eternal. We are learning to use cold for science. In space, frozen particles reveal the origins of the universe. On Earth, scientists create superconductors at low temperatures. Cold becomes our tool for discovery. Even during the toughest missions, astronauts know cold is a constant companion. It's invisible, yet always present, just beyond the ship's walls. One step into open space, and the temperature drops instantly. This thought keeps humans ever alert. And yet, humanity has learned to conquer space. Our ships sail through the frozen void, defying its silence. Every launch is proof of warmth overcoming cold, and a step toward our future among the stars. The cold of space reminds us of the fragility of life. On Earth, warmth sustains oceans, the atmosphere, and our breath. But one step into space, and all of it vanishes. We exist only because of a thin shell of warmth around our planet. Space seems to test our endurance. Every mission is a challenge. Every mistake could cost lives. Cold makes these trials even harsher, but it is what makes our victories meaningful. When we gaze at the stars, we see fire through ice. Every beam of light has traveled billions of kilometers through frozen darkness. It reached our eyes only because it survived the void. And within that lies the miracle of existence. The cold of space is terrifying, yet beautiful. In this silence, new worlds and galaxies are born. From frozen emptiness, life bursts into light. The universe is an eternal dance of cold and warmth. We are part of this story. The cold of space has not stopped us, but made us stronger. We are learning to create warmth where none exists. And one day, humanity will reach even the most distant stars. Space teaches us to cherish simple things. The warmth of fire, sunlight, the breath of wind, they feel ordinary. But in the cold darkness of the universe, they are priceless gifts. Cold makes us grateful for life on Earth. Scientists continue to search for worlds where cold and warmth are in balance. The so-called habitable zone around stars is rare. Only there can water remain liquid and life become possible. We are looking for new warm islands in the cosmic cold. Every discovery reminds us space is not friendly, but it is fair. It is indifferent to life, yet allows it to exist. Cold and warmth are not enemies here, but parts of one balance. And this balance makes the universe possible. The more we study the cold of space, the clearer we see the value of warmth. It is warmth that makes our dreams of the future possible. Warmth is our hope, our energy, our path to the stars. And cold is the eternal backdrop against which life shines. The universe is cold, but within this cold lies its greatness. It makes every spark of light precious, every sunrise, every star, a miracle. And perhaps that is why we long for the sky. Space is cold, yet it makes our existence priceless. We are a rare spark of warmth in the endless frozen void. Every step forward is a victory over eternal cold. And as we look at the stars, we realize this cold is only the backdrop to the greatest story of life.